Welcome, Algebra 2 students. We are in Lesson 41, and we're going to talk about estimating with scientific notation. So, scientific notation is all about being able to calculate data rapidly. So an even quicker way to calculate data rapidly and to write it in a type of shorthand and transfer that information is to estimate your scientific notation. So what I mean by that is we're going to take these numbers and we're going to estimate them. But you don't want to put all of this in a calculator, because what happens is you either get an error message or you get a scientific notation number anyway. So if we kind of know what scientific notation number to expect, then we can say, okay, I typed all these numbers in correctly and I'm good, or I'm way off the mark, I need to type them in again and get a better answer. So when we do a quick estimation in scientific notation, we can figure that out. So what we're going to do is we're going to look at 16, and we're going to picture the decimal here, because that's where it would go. We would say 16. In scientific notation, that would become 1.6 times 10. We don't want 1.6. We want a whole number. One whole number is all we want. So that's going to estimate to 2 times 10. All right, so now we have this number. We are going to turn that into 5.280 times 10 to the third, because we moved it 3 decimal places. We're going to round that up, and that's just going to be 5 times 10 cubed. But it is cubed, so we're going to put the cube on the outside of that. And now we have this 12 to the 3. So you can do 12 to the 3 one of two ways. You can either treat it like this, where you say 1.2 times 10 becomes 1 times 10 to the third, or you can multiply it out and you end up with 12 times 12 times 12 is 1728, which becomes 1.728 times 10 to the third, which would estimate at 2 times 10 to the third. So you could use this one or you could use that one. It's still 10 to the third, whichever number you decide to use. I like to use this number simply because it's fewer things that you have to calculate. You don't have to cube this. It's already cubed. That would be the only reason to do it that way. The book does it this way. So we're going to do it this way as an illustration. This is just as accurate. In fact, I'll come back and show you this with this number system. So we would have 2 times 5 cubed times 1 cubed, which would be 250, right? Times 10, and then all we do is we say this is 1, okay, this is 9, and this is 3. So 9, 10, 11, 12, 13. But we need to have one decimal place. So this would round up to 3, so it would become 10, or 3 times 10, and that would be plus 2, so that would be 10 to the 15. And that would be our estimation for this number. When we type this into our calculator, what we end up with is 4.0, and I think it is 697. Yeah, 697. The calculator spits out times 10 to the 15. So our exponent 15 matches. So that tells us that we got this estimation correct, and it's really close to this number. 3 and 4.0, that's only 1 digit off. So we got that correct. And whenever you write this, you always write it with approximately. It's not equal, it's approximately equal to. And that is like, it's like a caveat. It's like, I said approximately equal to, not equal to. So if we wanted to do this the other way, where you go ahead and multiply this, because it's a small number, and we would have this 1.7 that we rounded up to 2, you would have 2 times 5 cubed times 2, okay? And it wouldn't be cubed because we've already done all that. So we would end up with 500 times 10, and that would be still be 13 because you have a 3 here. So it'd still be 13, and then we would go 1, 2, and then that would be plus 2. So that would end up at 5, approximately 5 times 10 to the 15. So if you did it this way and you did it that way and you had this number in between, then you know that is the number that you should expect. You should expect something about halfway in between whenever you do both methods. Okay. So this is the exact scientific notation number, and these are the approximates, and it's about halfway in between. So that tells me that our estimates are valid. So that gives us a range of what to do. So let's try some of these scientific estimation problems. Let's do 41. It says 41, 42.1. Let's clear this page. So actually, we just did 42.1. So let's do 42.2. So I'm going to write the number because it takes a while, and then you can see it. All right, so here is our problem that we need to estimate. So let's break down the numerator first. So we need to, first let's set it up. We'll set up this one. All right, we need to find 1, 2, 3. So this is going to be 3. Actually, just clear that. This will round this up to a 4. So it's going to be 4 times 10 to the 3. You see where I'm going with that? 37 is rounded up to 4. So 3.7 rounded up to 4. Now let's look at this one. We have 1, 2, 3, 4. So that's plus 4 in the first place. Is that right? 1, 2, 3, 4, 5. I miscounted. That was 5. All right, so that is 4.7. So that's going to round up to a 5 times 10 to the negative 9. Now we do the bottom. We have 1, 2, 3, 4, 5. 2.7 rounds up to 3 times 10 to the 5th. And then this one is going to be negative 1, 2, 3, 4. 7.1 remains 7. And that's going to be minus 4. So that's going to be times 10 to the negative 9. All right, so now that we have our estimates, we can do our calculation. So we're going to do 4 times 5. So that's going to be 20 times 10. 3 plus negative 9 is going to be negative 6 over 3 times 7 is 21 times 10 to the negative 4. We can reduce this even more. So we're going to move this back 1. So that's 2 times 10 to the negative 5. And we move this one more, and 2.1 rounds back to 2. That's going to be 10 to the negative 3. So now this becomes 1 times 10. And when negative 3 comes up here, it becomes positive 3 because the sign changes when you flip sides. So it's going to be a negative 2. And this is approximately equal to, because all of these are rounded, so that makes them estimates. So we say approximately equal to, not equal to. Right? Anytime you round a number in a calculation like this, you're going to use approximately equal to is the correct way to express that. So that's the answer to 42.2. So let's do 42.3. All right, so we have another very long number, so I'm going to pause and write it. All right, here's our problem. So let's first of all reduce these and estimate them down to where they're manageable numbers. So we're going to move this decimal place back 1, 2, right, to 4.1. So that's going to be minus 2. So that's going to become 4. We can't round this up. 4.1 is staying 4 times 10 to the negative 16. And then that's going to be, we have 1, 2, 3, 4. So that's plus 4. So that's going to be 4, and we can't round this up. So 4 times 10 to the 47. Okay, and then that's going to be over 1, 2, 3. We can round this up to 10, but we don't want to leave it a 10, right? So that would be 1, 2, 3. So plus 3 would make that 10. So we'd round it up, go up one more space. So it's going to be plus 1. So that's going to be 1 times, that would be 20, that would be negative 19. 10 to the negative 19. Okay? So we see how that works. So now we can do our multiplication. So 16 times 10 to the 31 over 1 times 10 to the negative 19. We want to move this, so that's going to be plus 1. So that's going to equal, but we can round it, so we want to do 2 times 10 to the 32 over 1 times 10 to the negative 19. That reduces to 2 times 10, and when we take this upstairs, we add it. So that's going to be 51. So 2 times 10 to the 51 is your answer here as an estimation. So it is approximately equal to 2 times 10 to the 51. And if you don't know where to get the approximately equal to, it is in your, I think it's in your algebra keyboard. Yeah, I'm pretty sure it's in your algebra keyboard that you can get that. If not, I will look for it and see if I can give you a custom keyboard. But anyway, that is all we have for lesson 42. So I'll see you in lesson 43.